Hello and welcome back. It looks like we've got another geometry question here. Let's have a look. When viewed from above, a swimming pool can be seen as a rectangle with a semicircle at each end, as shown in the diagram at right. The area around the outside of the pool, extending 1.5 meters from the edge, is to be paved. Find the area of the paved section. Okay. Well, if we look at this outside edge, we can see that we've got two vertical rectangles, and one is just 10 meters tall and 1.5 meters wide, and we've got two of them. And also we've got a circle inside of another circle. If we think about our two semicircles, we could just put them together like this. The smaller radius on the inside would equal 2 because our diameter is 4, and the radius of the bigger circle, I'm going to use a capital R there, that would equal 3.5 and meters for both there. Ooh. Perfect. So if we just look at our rectangles first, the area of those rectangles would just be 10 times 1.5 times 2, because we've got two of those rectangles. And I'm just going to call that area 1. So the area of that will just be 30 meters squared. Now if we look at our semicircle, we want to get the shaded area on the outside, because this bit is getting paved and the internal section is just the pool. So area 2, that's going to be the area of this shaded section. So if we worked out the area of the larger circle and we cut out or we took away the area of the smaller circle, we'd have our shaded area. So that would just be pi capital R squared minus pi little r squared. And if we substitute our values in, we'll get pi times 3.5 squared minus pi times 2 squared. And if you pop that in the calculator, you will get 25.918, etc. meters squared. 3 decimal places is usually good enough for geometry. But we want the total area of the paved section, so let's add that up. So the total area will just be 30 plus 25.918 approximately, and that will just give us 55.918 meters squared. And that's it for the area of the paved section. Now for part B. If the pool is to be filled to a depth of 900 millimeters in the semicircular sections and 1500 millimeters in the rectangular section, what is the total capacity of the pool to the nearest liter? Okay, there's a lot going on there. So we've got two distinct volumes we want to find. We want to find the volume of the semicircles. Well, how about we say the volume of the circle, because we know if we put those two semicircles together at the end, it'll make a circle. So the volume of the circle would just be pi r squared times height, because obviously it's going down into the pool so that it has water inside of it. So this will just be pi times 2 squared times height. Now if we use 900 here, we would get a very large answer. But in the diagram, everything's in meters. So let's change this depth or height to meters. So 900 millimeters, that's the same as 0.9 meters. And the volume of this, if we just calculate it, we will get something approximately equal to 11.310 if we round to the third decimal place. And that'll be in meters cubed. Now, if we look at the rectangular section of the pool, the volume of the rectangular section, that'll just be length times width times height. And that's 10 times 4 times 1500 millimeters deep, and if we convert that to meters, that would just be 1.5 meters. And if we calculate this, we will get a volume of 60 meters cubed. Obviously, we want the total volume. Total volume will just be 11.310 plus 60. That's going to be 71.310 meters cubed. Now, the question does ask for the capacity, not the volume, and it wants it to the nearest litre. So we've got to convert meters cubed to litres. So if we recall, we know that 1 meter cubed is equal to 1,000 litres. So we just have to multiply our total volume by 1,000 to make it into litres. So that would mean this volume as a capacity will be 71,310 litres. And we've answered it. We've got it to the nearest litre. Make sure our units are correct. Fantastic. Alrighty, that's it for today. Thanks for joining me, and I'll see you next time.